Good morning. We are going to work out of section 12.1. This is in volume 2 of your textbook on page 848. So you're probably going to need to pause this video and get there first. So what we're going to do is talk about exponential equations and their inverses, which are called logarithms. That's what this entire chapter is based out of. So we're going to start with exponential stuff. So some of this stuff will look familiar as a review of some of the material that you guys learned like last year. But yeah, we'll just start by completing the table basically. It says Allison and Beth each receive $10 per week for doing chores for their neighbor. One day Allison decides to increase her income using knowledge of exponential growth, which you guys have seen now from doing the sequences in series. The geometric sequences were exponential ones, and the arithmetic sequences were linear, which means they'd be going up by the same amount every time. So she proposes that her payment be charged to a penny and then doubled each week after. So notice that her income on this table for the first week is going to be 1 penny, and her friends is still staying at $10. So what I'm going to do is double her amount for every time here. So she would really end up with 2 cents, and then 4 cents, and then 8 cents, 16, 32, 64, and $1.28. So she gets a whopping $1.28 after 8 weeks, but you'd be amazed a little short amount of time. Her amounts are going to start doubling and getting larger and larger. Her friend, meanwhile, is getting $10 each week more. So she's getting a constant $10. That's what they're looking for. So this is the amount that you're adding to her initial amount every week. So again, this isn't their total, it's just the amount that they're getting every week. So she gets paid $1.28 on the 8th week. She got paid 64 cents during the 7th week. So you would like add all these totals up if you wanted to figure out a sum. Which again, this would kind of look like a finite sequence right now, and we could turn it into a series if we did want to add all these dollar amounts. How does Allison's income change as the number of weeks increases? So her amount is doubled. So we're going to write it's just multiplied by 2. And then does it represent the arithmetic or geometric? So as I kind of already mentioned, this would be geometric because it's exponential. Blah, blah, blah. So I'm going to write it represents exponential growth. Which is what we would call that when our amount is getting larger and larger. It just says state the general formula. So this would be stating the explicit formula for a geometric sequence, which is where we took our first term times the common ratio to the n minus 1 power. So if we're going to write one for Allison's income, we would say Gn equals, and we're going to take her first amount, which she started with 1 penny, times the common ratio of 2, and that would be to the n minus 1 power. Alright, so we could use that to evaluate her income after n number of weeks. That is not in function notation, that is just the explicit formula. It says what is the value for, basically what is her starting amount for when n equals 0, and does it make sense in the problem situation. So if we kind of go back a slide, notice that this is the amount that she's getting in week 1. What we're really solving for is what would happen if there were this week 0. So if I say, I'm going to use, and we're going to use g's instead of a's. If I say gn equals, and I took 0.01 times 2 to the n minus 1, and we are going to be evaluating g of 0, you would just basically substitute 0 in for n. So go through the calculator. Where's mine? So I evaluate this. So 2 to the negative 1 power times 0.01. I get an answer of 0.005. It says, does the value make sense in the problem situation? So we already know that she starts off the first week. Technically, she started with 0. So she didn't start with this dollar amount. Also, this dollar amount, if you think about it, if 1 penny is 0.01, this is representing half of a penny, and that's kind of cray. We can't have that. So the value really doesn't make sense in the problem. She would be starting with 0, but it just didn't show up that way. It's just the way the equation works. If this pattern were to continue, how many weeks would it take for Allison's income to be larger? So this is where we're going to see if she really is a smarty pants by basically putting down the 9th, 10th, and 11th week. And if I were to double back from where our table was before, she would end up taking the $1.28, and if she doubles that, she has $2.56. If she doubles that, she has $5.12. So when she hits this 11th week, she gets paid more money because she gets $10.24. While Beth is still just sitting here getting the same old generic $10 every week. Arithmetic, it's boring, it's linear, blah, blah, blah. Okay. Allison's, though, if you do think about it, by the time she hits her 12th week, she's getting paid $20, and then $40, and then $80, then $160. So she's getting a lot more and more money, and that amount is going to keep growing a lot faster than Beth's is, and it's because it is exponential. I like this section. It's so much fun. Okay. So this is like a really important section. It says you can write the explicit formula for the geometric sequence like this, like we had, but we can express it in function notation. So it's going to go through all this like things right here, all this work with all these reasons and all that fun algebra. But what you really have to pay attention out of this is we just want this thing to be written so that we don't have n minus 1. I want to write it so that it's just an n. So we have to find a way to get rid of the minus 1 basically. So what they're doing in this line right here, where my cursor is they're breaking it up into 2 to the n times 2 to the negative 1. So if you think about it, we really have that n minus 1. It was one of the rules that we'd learned about exponents way back in the day. So if you simplify it after that, so just kind of follow the work here, this doesn't change at all. If you go in your calculator, 2 to the negative 1 is 1/2, if you don't believe me. And then you can simplify this. What they did is just flip this around. They're bringing this here and this here for no apparent reason. And then what they do is multiply. They're multiplying the 1/2 by 0.01 to get this value times 2 to the n. So here's your function notation at the very end of all that madness. And we're going to do some examples. That was like a really long process, it seemed, but it'll make more sense if we work with it a little bit more. So we'll go on calculating this. I'm going to write the function that they had from before. Fn equals 0.005 times 2 to the n. And we're going to evaluate this for all these different inputs. So for this first one, we're going to do f of 15 equals 0.005 times 2 to the n. And we'll put 15 up there. So one of the things to note about this that's really nice, since they're exponential, your calculator will do the order of operations for you. So you could just put in 0.005 times 2 to the 15th power, and it will give you an answer. And this comes out to $163.84. I'm going to skip down so that we can get into the really interesting one, which would be the 24th week. So if I do f of 24, same exact thing. You're just putting inputs into an equation. And 24 becomes my exponent. So if I go in the calculator for this, 0.005 times 2 to the 24th power, she's getting a lot of money. Holy crap. Okay, $83,886.08. Don't forget that 8 cents. That's like how much she earned in the 4th week. So notice again, as the weeks go on more and more, like if we went to the 25th week now, if you play this out kind of like a sequence would, in a sequence, if your common ratio was 2, you would multiply by 2 to get to your next term. So if I wanted to figure out how much she would get in the 25th week, I would just have to multiply this total of 83,000 by 2, and that would tell me how much she's getting. So she'll be getting $1 million a week within a matter of, like 5 weeks or something like that. Kind of like my salary, but just not at all. All right, going on. So it says predict the shape and the characteristics of this. All that I'm really looking for is you guys realize they're both starting off with $0. So this would be our time down here. This would be the amount of money. Her friend Beth, which I'm just going to draw a line. This is going to represent Beth's line. She is going to be the linear equation. She's getting the same $10 every week, rise over run, same $10 per 1 week. And then if you think about Allison's, well, she was like going a lot lower. And then slowly what happened is hers started going increasing, then it was growing like insanely fast. But they did hit a point where they did crisscross. So there was a certain number of weeks where their two curves did meet. We'll be able to finally solve for that with using algebra and not just the graphing calculator. So that's kind of some of the cooler stuff to come, is that in the last math class, when you guys learned this the first time going through exponential equations, you never really did learn to solve them by hand because you need to learn the inverse operation, and logarithms are that inverse operation. So we will finally be able to solve these using algebra. Problem 2. So we're going to talk about kind of going in the reverse way. Beth's amazed at how quickly Allison was able to make her money, decides she wants to do this, so she says, blah, 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 you could start with $1, and you could ask her 50% more each week. And then her friend says you could start with $1 and add another $1 each week. So which plan should Beth choose? Well, again, one of these people is saying that this sounds more exponential because it's a percentage. You're asking for 50% more each week. And Alicia is saying you should be adding the same amount every week. So this one is linear. And this one over here would be your exponential. So whose plan should she choose? I would maybe choose the exponential one, but since it is looking like the number is less than 100%, it means that the amount she would be getting would actually be getting smaller and smaller. So let's take a look through these tables. What I'm going to do is pause this video so you're going to see some magic when I turn it back on, and I will just have all this stuff complete. But I would like you guys to get this started. Both of these people are starting off with $1. And Alicia's plan, so this is talking about the total after each week. So then this would be $2, $3, $4, blah, blah, blah. Her friend is going to be getting, if you go in your calculator and you times by 1.5, you would have $1.50. And then I would take $1.50 and also multiply by 1.5. You would get 2.25. So I'll have you keep going down this chart, fill this in, and then graph them, and round to the nearest hundredth on this first column just because it is dollars. Okay, so here's the two plans then after I finished. So again, Quentin's plan was multiplying by 1.5 every time, so his amount was growing more and more and more. And Alicia's plan is just growing by that same dollar every time. So notice after this really early on kind of point, after 4 weeks already, Quentin's plan passes, and then it looks like his dollar amount is like even double what Alicia's is by the time it's like 3 weeks later. So the exponential one really does grow a lot faster. Even if we're not doubling, we were multiplying by 1.5. Like I said before, like really early on when it says which one would you recommend Beth take? Well, it really does depend on that percentage, because if we have a really low exponential percentage, like if she were only growing like 2% every time, then it wouldn't pass her up right away. So it really does depend on the amount of time, and that's kind of the stuff that we'll get into throughout this chapter. The next questions are going to talk about just writing a function for this. So for Quentin's plan, we're going to use q of x, which that was the one that was exponential, and started off with $1, times, you would just write the common ratio here, and then this is to the x power, and her friend, which is Alicia, so this is a of x, equals, starting off also with 1, but since this one's linear, you are adding 1x every time. Okay, so it says, use your choice from question 1, determine how much Beth would earn in week 10. So that's if she were to go with Quentin's option. We're assuming that she's going with this exponential one because she's a smarty pants. So q of 10 would be 1 times 1.5 to the 10th power. And again, you can just throw this right in your calculator from left to right, which is the same thing as 1.5 to the 10th power. And she would get $57.67. So again, while the other person is just increasing by $1 every week, by the time we are to the 10th week, she's already making $57. And then you would multiply that by 1.5 for the 11th week, and that would give you another larger dollar amount. So it says if Beth and Allison both start using their exponential model to earn the income at the same time, who would earn a higher income by week 12? So I'm going to use Beth's equation, which is going to be the one that Quentin used, the one that we used for number 3 here. All these friends and their names, and okay. So Beth's one, we're going to be evaluating q of 12 So we're going to do 1 times 1.5 to the 12th power. And for Allison's, what we're going to be doing is evaluating that function that we had before, the one that had the 0.005, the half penny thing, times 2 to the 12th power. So if you evaluate these two, Beth's on top would come out to $129.75, and then Allison's would come out to $20.48. So let's kind of think about why these numbers are as different as they are. This top one, even though it's a smaller percentage, what it really comes down to is she started off with $1. If you think about Allison's problem, the first like 6 or 7 weeks, she was still earning under $1 because we started off with a penny, and then it was 2 pennies, and then 4 pennies, 8 pennies, so on and so forth. But it was starting off with a lower dollar amount. It took her a really long time to catch up to the whole numbers, whereas in Beth's, she's starting off with $1 right away. So even though her percentage is smaller, starting off with a larger dollar amount is what earned her a lot more money over that short amount of time. So to use a graphing calculator, we're going to determine when their incomes would be equal. So in the graphing calculator, hopefully you guys have a graphing calculator, we are going to put both of our equations in here. So what you'll need to do is go to y equals, and we're going to enter in both of these equations. So I'll enter in the Allison one first, 0.005 times 2 to the x power. And then for Beth's, I'm going to be doing the 1 times 1.5 to the x power. And then as far as our window goes for this, I'm going to go from 0 weeks all the way up to, let's do 20 weeks, and I'll count by 2's. And then why don't we go from 0 to, because it's going to be such a high dollar amount, let's say we're going to go to $2,000, and I'm going to count by hundreds. So I'll leave that up there for just a little. My graph went away. Okay, so now that I have my window, take this window down, and then I'm going to hit graph. And hopefully we're going to see 2 curves on here. There's one of them. Bam. Okay, so it looks like I hit the intersection on here. So what we want to do is go to second and trace, and you're going to go down to the 5th option, which is intersect. And then you're going to hit enter a few times, and it'll hopefully calculate my intersection all the way up there. There it is. So it wants to know how long it'll take, which would be our x value. So it'd take 18.41 weeks. And then that dollar amount would be $1,750. So 18.41 weeks would be our answer. And it does make sense because, again, considering the rates that they're growing, one will surpass the other one of these. Blah, blah, blah. What's after this? Okay, so here's what you guys are going to do. Because I'm running short on time, and this video is getting long, you are going to come back to my desk. I have my book out. You're going to copy the answers for problem 3, which is on page 853 all the way to 856. If you could, like, attempt to try these yourselves first and then come back to my desk and copy the answers, that would be like the most ideal choice, because you do have the rest of the hour basically just to work on a 1-page homework assignment. So I would really urge you to work through problem 3 in small groups and then come to my desk, get your answers, and then do the homework. Bye-bye.